Hi Emilio, great to see you. Thanks for taking a little bit of time for me today. So we're here today to talk about what's new with the SEMITOP E series.
That's correct, James. We have two packages, the SEMITOP E1 and the SEMITOP E2. So these are standard industrial packages. Many of our competitors have a similar design, but we've basically taken that and tried to improve it as much as possible, such as making a lower resistance chip to heatsink design, but also coming out with new portfolios, such as for Generation 7 IGBT and Silicon Carbide.
Okay, so today we're here more to focus on new chips rather than new topologies, is that correct?
That's correct, James. So we have really two focuses here. We have Generation 7 IGBTs, so we have the T7 IGBT going into the converter-inverter break topologies and the 6-pack topologies. This is mainly geared toward motor drives, a more efficient design, but also more of a compact design. In the same package, we could go from a 75 amp half 6-pack up to a 100 amp 6-pack with Generation 7 IGBT.
Okay, so these new chips are going to enable a higher power density for the drives manufacturers. So what's that going to mean to their product?
Right, so for their product, they basically can have a similar package size with more output current, more power, really increasing the power density, but also ensuring that they don't need to go to that next step and reduce material costs as much as possible.
Okay, you also mentioned Silicon Carbide. What are we doing on that front?
So with Silicon Carbide, we realized that there are a couple markets moving very, very strongly towards Silicon Carbide. For instance, electric vehicle chargers. They really need a high switching speed and a very power-dense design. They're trying to fit the chargers in an area where the cars go, parking lots, small spaces. So we're really offering a full Silicon Carbide portfolio geared around the EV charging market so that we can have very high switching frequencies up to 100 kilohertz plus, but also very power-dense designs.
Okay, so when you say EV charger, this is not onboard charging, but actually charging like we see on the street, as it were.
Correct. So this would be the DC fast charging that you would see on the side of the parking lot.
Okay, great. And are these products available immediately?
We have samples available in the Silicon Carbide, basically up to 250 amp half bridges. And we have those in the standard industrial pinout, but we also have them in an extra pinout that we've made for really simplifying PCB board design and paralleling. And for the motor drive application, we have not only the T7 chips, but the IGBT4 and the IGBT3 that are available for purchase.
Okay, great. Thanks very much, Emilio. Sounds good.
Thanks for having me, James.